Yeah, I'm excited. It's a privilege to get to share this work with you because I'm really passionate about this work and also raising awareness for seabirds in Hawaii. And I know a lot of people in this audience are already very familiar with seabirds and passionate about them as well. And Oikonos Ecosystem Knowledge is a nonprofit that I work for, and we collaborate with a lot of different people. And today I'm going to tell you about our project that really involves combining art and science to create safe habitat for seabirds, especially the shearwater here. And this project has a lot of partners: Hawaii Audubon, Windward Community College, California College of the Arts, and Hawaii Pacific University. And Oikonos works throughout the Pacific. We're a small nonprofit. We have passionate leaders that are working in Chile, California, and Hawaii. And our mission is to study and protect imperiled ecosystems. And one thing that makes us unique is that we try to combine scientific and artistic expertises in our collaborations and our projects. And here we work just up the road at Oceanic Institute with Hawaii Pacific University's Pelagicos Lab. That's David Heirenbach's lab and his students. And we also have about 15 other island partners that we work with. And Oikonos' work here, we mainly protect seabirds, work on documenting plastic pollution in seabirds and their prey, improve habitat, and we also have an education program called Winged Ambassadors. So today, I'm going to go through artificial nests, give you a little introduction of nests as a conservation tool, talk a little bit about art and science collaborations, and why ceramics, and talk about some solutions that we're going to work on for Hawaiian seabirds. So artificial nests are a very common conservation tool, and they're used for many different taxa. And of course, we're all very familiar with birds. They're used as bird boxes. And they're usually applied to increase space, to improve space for animals, or to allow data collection, because a lot of animals are in places that are hard to reach and they're really hard to do research on without disturbing them. So here's a great example. We think of a sanctuary as something on the land, and here's a sky sanctuary. These are artificial sites. And other taxa besides birds, there's a lot of innovation for bees, of course. And what's happening now is they're doing 3D printing and a lot of things so that the beehives can flow the honey out so you don't have to disturb the hive. And then the bats there, that is a predator protection there on the post to protect bats. So these are just some examples. And then for seabirds, these are global threats for seabirds in many different places. They have degraded habitats and they have predators. This is a picture of the island I've spent a lot of time on, Año Nuevo Island in California. And these are holes that a bird related to a puffin, it's called a rhinoceros auklet. This is the habitat that they're trying to nest in. And the main problem is that our habitat's either overdeveloped or it's degraded from past use. This was a Coast Guard lighthouse station, and they just left the island with all the trash on it. And then, of course, we're all familiar with cats as a predator, and Hawaii has other land-based predators as well. And specifically for seabirds, nest boxes is what they're usually called. They have been used for a long time, and usually for the seabirds that burrow. There's birds like albatross that nest on the surface, but there's a whole group of birds that burrow underground or nest in crevices. And that's especially useful to prevent their erosion and prevent a lot of their threats by using artificial sites. And in California, for example, here's a study on the Farallon Islands, which is off San Francisco. There's 400 of these nest boxes out on the Farallon Islands. So that gives you an example of the scale. And this has been done since the 1970s. They have an amazing amount of data. And artificial nests can help facilitate research. This is actually out on Flat Island. It's Popoia. This is the deal and our crew looking for bulwers petrels. They're bulwers, petrels, and shearwaters nest out on Flat Island in the little uplifted holes in the reef. And they're really, really hard to work with. And if you have an artificial site, the alternative is you can lift up a lid or pull out a tunnel, and you can have access to the chick or the egg, weigh it, measure it, and see how they're doing. And you can get amazing data. This is showing the number of chicks that are produced per breeding pair, and you can see the top of that scale there is 1. So this is a species that only lays 1 egg. So the most it could produce, the most success it could have would be 1 chick. And it just shows you, this is over like 20-year time series, just in artificial nests. And it gives you an idea of warm years, cold years, what happens with the birds. You can see dips, you can see patterns. And this is just a great research tool. And my passion in this project was that I had worked with, for over 10 years, with nest boxes. And I really wanted to improve the materials and design because all the ones we work with are made out of plywood and PVC. And almost every year we were having to buy more materials and maintain them and fix them and build new ones. And they rotted when you buried them. And it was actually a huge time sink, and so it was just unfortunate that we had to spend our time on this, and I thought there must be a better way. So this is another example of the bigger nest boxes that we used for years. And there are a lot of collaborations between artists and scientists. One of the most traditional ways is that artists interpret science through books and in other means. But there are many different other types of collaborations, and I just wanted to introduce you to this term. It's a little jargony, but transdisciplinary collaborations, which basically means you bring in 2 expertise, 2 disciplines, and you create something new out of it. And I think that we've approached this by having ceramicists and scientists work together to create ceramic nests for seabirds, which didn't exist before. And we spent a lot of time thinking about clay, and I wasn't familiar with ceramics at all. And the one thing great about it, and I've learned a lot about clay, is that it is sustainable, there's no toxic additives, and it's strong. A lot of people feel like, oh, it's too brittle, you can't build something out of clay and have it be durable, but it's just the opposite. And it's customizable. For clay, you can hand build it, you can throw it on a wheel. Now they're 3D printing with clay. So there's so many things you can do with it. And also it can be round as opposed to cement and other materials. And it degrades to dirt when we're all dead. And our grandchildren are dead, it'll still be there, and it will eventually degrade just to dirt. And we were lucky to collaborate with this lead artist. His name is Nathan Lynch, and he's at the California College of the Arts. And it was just fortuitous for us to get together. And this is an example of his artwork. So it already looks like habitat to me, but it gives you a demonstration that he's a really excellent hand builder. This is all built by hand. And there is a picture of him with a student making a big mold for a seabird. So that's another technique you can use besides hand building, is make a mold. And Nathan says, the idea that ceramics is either pottery, sculpture, or a toilet is unacceptable to me. It is more. And his lab's motto is make art that matters. So this was a great collaboration. So our challenge was to integrate what we knew about the birds, what we knew about restoration, what had worked in the past, with ceramic knowledge. And I had no idea what could work, what was possible, and all towards the goal of making a safe habitat, making it durable, and making it sustainable for the seabirds. This is a picture of Nathan. He's got the top off of a storm petrel nest there, and he's talking to the students about design. So we started this collaboration in 2010, and since then, what we've accomplished, that we've made new designs for 4 different seabird species on 3 islands. And over 150 chicks have actually fledged from these nests that we've installed on 3 different islands. And what's really fun is that 4 courses have been taught at the California College of the Arts. And this is a course in seabird conservation. And these are architects, artists, and designers, and they're taking a class on seabird conservation. And so we're really proud of this. Here's some pictures of the people at California College of the Arts, and the students are all very good with graphics and design as well. And the students did get to go to Año Nuevo Island, and they really enjoyed being in the studio and also in the field. And this is to show you, these are the number of breeding birds. that have been using the clay modules since 2011, the year after they were installed, to 2017. And these are the 3 species that moved in. And I want you to note that we were only intending on this bottom guy. This is the rhinoceros auklet. It's related to a puffin. They were built for the rhinoceros auklet, but Cassin's auklets moved in and the pigeon guillemots moved in. Just to give you some idea of the diversity of design, this was the first design that was made for the rhinoceros auklet, and they have really long tunnels. So we had to make an extra long tunnel for them, and just like a snail design, and these are buried underground, so we didn't have to worry about heat. And this is a chick inside of its tunnel. And this is a different design for a smaller relative, the Cassin's auklet, and this is where we started experimenting with sun exposure. So this has a sun shield on the top, and it has a feature there in the tunnel to prevent the western gulls, which are their predator, the western gulls from actually getting into that tunnel. As you can see, it's attractive because it's wide and then it narrows. That's another feature we used. And we really wanted to look at temperature because seabirds have been known in artificial sites, especially wood, to even die sitting on their eggs, because this is in a temperate area. This is in California, and they haven't evolved with the heat. So we're being very, very careful about heat protection. And of course, clay is so much better than wood as an insulation. Now, there's many places around the world, in hot places, where they've used clay for human dwellings for this purpose. And this just shows you that the blue is the highest temperature in the greenhouse, and then the red is the temperature that was inside the module. And these are just different techniques. Some of them are glazed. The ones that work the best, so the one in the very back there is a dome. And that was actually thrown. It's basically a huge helmet. And that worked really well, I think, because it has a big airspace. I was just giving you some examples. And this is another one that was designed for the relative of the albatross, the ashy storm petrel. They're tiny, tiny cousins of the albatross. They have the tube nose. And they nest in caves in California. And we didn't have to worry about sun here. They were in caves, but we had to worry about ravens. So we had to design a nest module where the ravens couldn't flip over. They were flipping over everything that had been made previously. So we made them 35 pounds. And there's 3 nests in each one of these modules. And the holes are too small for the raven to get its bill into. That was a big challenge. And now our new client in Hawaii is the Oahu, the wedge-tailed shearwater. This is a native seabird of Hawaii that used to be very abundant. Right now it's abundant on the offshore islands where there's no predators, and behind the Canada Point predator-proof fence. They're really increasing there, but they're also still trying to hold on in some urban environments. And one of them is the Freeman Seabird Preserve. And this is managed by Hawaii Audubon Society. And so the wedge-tailed shearwaters, they'll spend time at sea, and then they'll have to return to land to find a mate. And so when they return to land, they have to decide where they're going to lay their egg and whether they're going to maintain their nest and where they're going to go. And you can get some more information here at freemanseabirdpreserve.com. And they're here a long time. They start to arrive about late March, more really activity in April, but they're here all the way through December. And at Freeman Seabird Preserve, they can be in soil or in rock crevices between the lava. And it's a lot of energy. That's a long time to just raise one chick. They only lay one egg. This is pretty common for a lot of the seabirds in Hawaii and elsewhere. Their goal is to have this little chick become fully feathered and healthy enough to fledge and go out to sea. And this is Freeman Seabird Preserve at the beginning. This is 2007, when it was donated in No More House. And you can see that there's 2 different kinds of habitat. On the terrace, there wasn't much heterogeneity or much habitat, but the slope was really prime habitat for shearwaters with in between the lava rocks. And Hawaii Audubon Society has done a lot of improvements between 2010 and 2017. These are rock condos. They love to nest inside rocks. So there's rock piles and rock condos. This is a lot of work to bring in rock, but they needed more space. And then with the help of David Heirenbach, From HPU, they tried artificial sites as well. These are tiles from Reuse Hawaii. The David wanted to give them more space, and these have worked really well. There's black tiles and there's green tiles. And now the new goals, learning what we've learned from those artificial nest sites and knowing what we know about the colony, which is that it's increasing. It's increased from 100 pairs, that's 200 birds, to 270 pairs. So it's almost tripled in just the 8 years since they've been monitored. And so we know it's doing well, and we believe that giving them more habitat and better habitat is the way to go. So our goal in 2018 is to improve the nest design, to install 10 to see how they like them, test out the performance, how are they breeding, how's the temperature, and then to use this project to also raise awareness about the birds and how we can all help them.
This is the Freeman Seabird Preserve, created in 2007 by the Hawaii Audubon Society for the conservation and protection of its native species, particularly the Oahu and wedge-tailed shearwater. These seabirds once flourished in the Hawaiian Islands and guided navigators to land, fishermen to their fishing grounds, and they were harbingers of changing weather patterns. But with man's arrival came development, invasive species, and the loss of native wildlife. But in recent years, research Dr. David has documented the return of nesting shearwaters in the preserve. Improving the available habitat by creating new homes has facilitated their recovery. Now, Windward Community College joins the California College of the Arts Ceramic Seabird Nest Program by learning about the seabird's nesting habitat and by designing innovative ceramic homes that exclude predators. Students are able to provide durable and environmentally friendly shelters that use their artistic ingenuity to benefit these seabirds. The students engage in Hanauma, which is a community-based stewardship effort to care for the land. Our project needs the support of a community, and your donation will help us towards our goal of building ceramic modules, immersing students in science and art-based conservation, and ensuring the research legacy of the Freeman Seabird Preserve. Mahalo nui.
Yeah. There's a little video that Windward Community College made, and they have been an amazing new partner for us. And of course, we wanted to bring this conservation tool to Hawaii, and we want to build locally. We want to use local students and local resources. And the Windward Community College has an amazing ceramic studio. It's managed by Paul Nash, and on the right there is Bryce Myers, who's the lead artist and a professor at Windward Community College. And there's David in the middle and Nathan Lynch on the left. This is a great new partnership. And so we're going to continue to partner with David at HPU to document the success of the project and continue working with Hawaii Audubon. There's Wendy, and she has done a huge effort to help with the vegetation. It's almost, there's a lot of native vegetation there now, but it's always a challenge with the grasses that are there. And we have some long-term volunteers, that Sean and Jay, that have volunteered for years to do the camera traps. And Jay's even putting out wolf pee. I think it's the wolf pee to try to discourage the cats. And so how do you make a safe shearwater nest? So I'm not going to ask this little guy, because this is one of the nests at the Freeman Seabird Preserve that collapsed. So this is considered not a safe nest. But we want them to prevent collapse, which is what happened to this one, to protect them during storms. We know we have squalls and storm events, even though it's pretty calm out there in Kahala, and to insulate them from the sun, to mimic natural sites in terms of size and shape so that it's a familiar site for them, and hopefully to last 30 plus years, because it's great. It's really hard to get grant money to do this type of work, and you want it to last a long time. And to be accessible by researchers so that the chicks can be monitored for their condition, and to exclude cats and dogs. So the process that we go through, first there's lots of ideas, and there's lots of prototyping, and there's lots of late nights with wine sometimes. And we're also starting to realize that first prototyping with cardboard is a good idea. So this was a cardboard night. And then experimenting with different designs in terms of how much space do they need, how long should their tunnel be, and how tall should it be? I mean, every detail you can think of, we have to go through. And after 3 months of going in the field and building on our past experiences of what worked, we came up with the first design. And this first design has 3 components. It has a module that has 2 sections where the birds can lay their eggs, so they can choose which one. And we also wanted to do that so that they had lots of options. They didn't have to hang out outside with the cats. They had lots of room inside. And the tunnel is going to exclude cats, we're hoping, and the sun shield. The sun shield is to protect them thermally. And so the process of making these nests, I'm going to take you through. And these are the artists contemplating, staring at clay. What do we do now? We've got Bryce. Clea came from California College of the Arts. She's a graduated student. Kari Marbo is UC Berkeley, and Nathan Lynch. And they have a great slab roller there, and they even taught us how to do this. There's an oceanographer learning how to roll clay. Of course, he has to make sure that it's measured properly. So this is the scientist part. And this created, we probably had to roll out 50 slabs of clay. And then the building starts. And this is Nathan and Kari, and they're both excellent, excellent hand builders. So they're building the nest modules. And it takes a lot of knowledge about when to build, depending on how dry the clay is, and making arches. Like to make these modules here, he basically had to build a bunch of arches so that it wouldn't collapse on itself. And these little vents, you want to call them vents or gills or louvers. This Nathan came up with one evening over dinner, and we haven't done this for any other species, but we realized that wind is an important thing out there. And this is to allow more wind to go through. And because the sun shield is on, it's still going to be dark. So this was a great feature that we started. And the tunnels. So we built the tunnels also with slabs. And those holes are for drainage to make sure that the eggs and the chicks don't flood. And this was a student that came out from University of Hawaii to help us. And that's Kari again. And this is what the inside of the tunnel looks like. So it's got a big opening to attract the birds, and then it narrows down, and then it opens back up again. So we're hoping that it's big enough for the shearwaters, but that the cats won't feel like they can go in there. And when you work with ceramics, I've also learned that it's important to work with wood as well. And this is in the sculpture shop at Windward Community College. Forrest is a volunteer at WCC, and what they're doing is they're making a template for the sun shields. So to make the sun shields, first we had to give them a little rest. And we really wanted it to match the environment, and we knew we couldn't make them black because we did not want them to overheat. So everything out there is pretty much black. But we thought, well, if we can't mimic this color, we can mimic the shape and the jizz or the look of it. So just like the rocks out there, we made the outside of the sun shields with texture like lava. And then they get a lot of love after this. They get sponged and bathed. And what this does is this is a certain kind of clay that has lots of grog in it. And it has lots of particulates. And so when you sponge it, the soft clay goes away and it brings out the grittiness of the texture. And also we wanted to make sure David didn't hurt his hands. So they spent a lot of time making sure it was smooth on the inside. Thanks. And here's a look at the inspection that had to happen, of course, after it's all done. And so these are tunnels and modules that are drying out. And drying is a long process with ceramics as well. You have to make sure they're dry before they go in the kiln. And the kiln, this is where they're drying. And the sun shields were very precarious to learn how to stack those. And they dry for a couple weeks, and then they spend 30 hours in the kiln. So the update is that we've completed 12 modules just last month, and they are all in the kiln at Windward Community College right now. So they're being baked. And David has the cameras and the temperature loggers. So we're almost ready to work with the students and work with the community and get them installed as soon as possible. As soon as they're out of the kiln, pretty much, we're going to go put them in at Freeman Seabird Preserve. And the one that did get fired, we were able to show at the Koo Festival. That was about 3 weeks ago. That was at Windward Community College. And it was interesting to see, it was such a foreign object that a lot of the kids had never seen before, so they were really interested in it. And you can see there's the sun shield on the right, the module, and then the tunnel. And the research questions, once these are installed, going to be how many are prospected, how many are occupied, what's the breeding success? Breeding success in these clay modules versus in the natural sites. And have we really been effective at excluding cats from going inside the nests? And then hopefully in the future, we have more and more birds in these modules. It'll be easier to do tracking studies. Tracking meaning finding out where they go at sea, because we don't have any idea after the breeding season where they spend their time and what their life is like at sea. And I just wanted to share with you where you can experience these shearwaters. And they do need more people to be their protectors, especially here on Oahu. This is a bird that was killed at Chums Reef, and there's dogs and cats that go through there all the time. And their habitat is also pretty fragile. So when you see shearwaters at risk, it's a good opportunity to tell people about them. Some people don't even know that they're there. And it's an opportunity to educate and inspire people to protect them. Flat Island is an amazing place if you guys can paddle out there, but with the kayak, they're not disturbed because they're all breeding in uplifted reef. So it's not an erosion problem. And they club, it's called clubbing. Out on Flat Island, all the adults will lay out, or a big group of them will be out right next to the trail, and they'll be in a club. So you can get really, really good looks at them. And there's a new colony at Kailua Beach Park that some community members are really trying to protect. And we've had some incidences there with them being harassed. So that's a place where they need protection. Canada Point is an amazing place to go out there behind the predator-proof fence. Once they put up the fence, the shearwater started coming in, and it's increasing dramatically, the population. And if you walk out there, even if you don't see the birds, you look for their burrows. You see mounds and mounds of sand that the shearwaters have made. And Chums Reef is a place we'd like to work next. It's a colony that needs help. And then in Sea Life Park, you can see rehabilitated shearwaters that Sandra takes care of. And in the future, we are hoping to hopefully put out more habitat at Freeman. We're hoping to deploy at places like Chums and Kailua, where we can also protect them from cats. And we're going to work on this process of 3D printing in clay, because it really requires, right now, the hand building requires expertise. And 3D printing is a way where you can at least replicate the design. It also takes expertise, but once you have the CAD design and once you have the machine working, you can replicate easier. And developing something new called sea nests. We're calling them sea nests because the birds are indicators of what's happening in the ocean. And we also want to be able to see what's going on inside them with scales, with tag readers, and cameras inside these nests. That would be an innovation coming up in the next 5 years. This is a design from some of the students in CCA. They were engineers in this class, and they were trying to figure out how to get a scale in the tunnel. And there's birds waiting for their upgrade right now. And there are many, many partners and volunteers, and it's funded right now by Disney and the Atherton Foundation. And we're always looking for more funding to keep it going. And this is Kirsten Moy on the left. She works for Oikonos, and she's been a volunteer here for a long time. And she did a lot to keep this project going. And the middle is Bryce, and there's David on the right. Thank you. Ready for questions?
You talked about cats. You have lots of predators in Hawaii. You have mongoose, rats, cats, ants, people. Which are the most effective worst predators here?
It depends on the colony. It depends on the colony. Yeah, because at this one, at Freeman Seabird Preserve, because it's in the middle of a high rent district, the mongoose are controlled and people don't have loose dogs. So the biggest threat here would be cats and rats. But rats, they're controlling for. There's a lot of these fancy New Zealand rat traps out there. So at this particular site, the most mortality is from cats. But it depends on the place. Yeah.
You don't have any ant problem?
No, not here. But yes, ants have caused some colonies to depart. They have caused, I think Chinaman's hat was extirpated, the birds on Chinaman's hat, because of yellow crazy ants.
Trying to point down loaded deadly nest.
Yeah, but they haven't seen any of the damage yet there from the bad ants. So far that's been really localized. I know the Marine Corps base had trouble with the yellow crazy ants.
I live up by the Freeman Preserve and volunteer up there. And all of the birds have started nesting already. So my question is, why are the modules going in next month?
Yeah, so
Because they've already started nesting.
Well, they haven't laid eggs yet. June 1st, around June 1st they lay eggs. So June 15th is peak, I think. June 1st they start, June 15th is peak. So right now they're doing their sexy stuff, yeah. And then there's a honeymoon period where they're almost there. They're all gonna leave pretty soon. And they're gonna be gone for, Wendy, they gone for 2 weeks? About 2 weeks, they're gone. So they're fattening up, they're on their honeymoons, and then they come back. So it is, I would have preferred if they were out before April, right? But this is how projects go too. But if I had to do it, if I had control over everything, I would have put them out earlier.
I've noticed that they kind of changed last year.
Yeah?
So, yeah.
In terms
I have a
of,
bunch of them right now.
meaning how active they are, or what do you?
Yeah,
Oh.
yeah. And there's actually, I think, more than there was last year, which is good.
Yeah, okay. Maybe the count will be even higher this year.
Yeah, so I was just curious, as to,
Yeah.
so the models were basically for the,
Yeah, but like I said, they have already done some mate bonding and they've already done some site selection for sure. So we've missed some of the site selection part, but we just need to get them out there as soon as we can, you know. So, yeah.
In a way, we're cheating because what we're going to do is the current nest sites that are tiles and that have poop and signs of activity, we will replace those to have a higher chance that birds will use them. So we're going to, scope out places that there seems to be activity, take some of the soil with the poop, put it inside so it smells nice and homey in there, So when they come back, they may say, whoa, house looks different, but hey, it smells like me, so I'm gonna go back. It's a way to make sure we get more occupancy so we can really test them with birds and see what the temperature does and all that.
so like they come back every year to the same place, right?
We don't really know that.
So
There's not.
like this year, I'm noticing they're not coming back to the same spot.
Yeah, I think that there's an advantage to that. So a lot of seabirds try to mate for life and they try to go to the same site because it's a known success. But there's a lot of mess ups, right? So they change. Yeah, Colleen, I'm sorry, Colleen.
Are you going to be able to bring some of the kids who created the ceramic stuff out maybe when they're at to see inside their fitness?
Yeah, so we're hoping to definitely bring the Windward Community College students that were really interested out. And then David's from HBU, his students are going to continue. He's teaching his bird class this coming semester. So there'll be more HBU students. And maybe next year we're hoping to get some middle school near Kahala. If you guys have ideas, that's to get more engaged. But we'll have to kind of plan that out better for next year, I think. Any other questions?
You went into a lot of detail about the outside of your structures. What about the interior decorating? Is there anything that you put in that makes it more homey for the birds with soil that's underneath, grass, or?
Yeah,
Pictures or what?
well, we put in soil, so we think that they like just the activity of digging makes it feel more natural. So we do put in a pretty substantial layer of soil. And then like David was saying, we'll bring in some leaves full of poop and some ground full of poop and bring that in there so it smells like them, because that's what's in their natural sites. And they're not that messy. They don't poop all over their nest right where they're putting their egg. But they're also not the cleanest birds, so there's lots of smells and things going on the other side. So.
They're neater than my kids.
Yeah, but there's no wall hangings. We actually tried to make it smooth in the inside, but also to feel like rock, you know. And there's holes. There's holes for drainage. There's a lot of holes on the underneath side, and there's holes with this design. There's a lot of holes for the air to flow through with the sun shield on top. Yeah. Oh, and some of those holes are to hold the temperature logger too, because we've had a lot of trouble getting the loggers to hold. So this time we just said, let's just make holes in them so that we can put a cable tie through there.
I guess like either defining holes for the nest on the mainland, or is that...
Yeah. So every time we do this, we come up with our bigger toolbox. So we're definitely going to consider this for other sites. In California, most of the temperate birds, they dig really deep, and so they like dark. And when they can see light, they think that there's a problem. They think there's been a collapse. But the tropical seabirds, sometimes they'll just lay an egg under a bush, so they're not as sensitive to light. So I think for other tropical applications, for sure, this could work. So.
Can leave these birds lay eggs up on the side in the where it would be one of those are being made would be highly available along the sides of the mountains without the predator issue.
Oh yeah, you mean like the vertical cliffs where the predators can't get to? Yeah, like in some places in Hawaii, seabirds have been limited to these vertical cliff areas like white-tailed tropic birds. These shearwaters used to be everywhere, even high elevation, but the newel shearwater from Kauai, that species enjoys more of the high elevation habitat. We haven't seen any wedge-tailed shearwaters in the mountains of Oahu. So, but you'd have to escape predators in Oahu. I'm not even sure that our cliffs are good enough, you know.
I was just curious, I've been to Chums had a few times. I've never seen nesting seabirds out there, or even birds hanging out, seabirds. Is it the ant is the problem, or is there some other problem out there?
Well, the ants, my understanding is the ants caused them to just abandon the island, but I heard they're starting to come back. Okay. So next time you go out there, see if you can see little crevices or smell around or something. I'm not sure how many have come back. Wendy?
Well, I'd just like to mention that obviously, like the Oahu cliffs, it would be a great place for those birds to find holes. But mother-in-law remembers, and she's a relatively modern person, going back into the Polynesian times, going to Montagu and taking eggs out to eat. So there were human predators at work.
Yeah.
Not that distant.
Yeah, yeah. In the islands where we work in Chile, we still have, they're still hunted to eat. So that's another challenge.
In the beginning of your talk, there was a slide, it wasn't a subject you had talked, but about fledglings for mating pairs over a period of years. And there was a big dip right in the middle. Was that a weather-induced thing, or predators, or food, or what?
Yeah,
There's a huge dip.
That dip you saw was warm water, and the anchovies and the rockfish disappeared from California. So that was a warm ocean signal. So what was interesting is we knew from the trawls that the anchovies had disappeared, but then the birds also told us that this is a signal. It's an El Niño thing, yeah. And California had some other warm water events they're calling the blob. So it was a combination, yeah.
You guys find that shearwaters eat? I know squids is one of them, but I don't know if they eat.
Yeah, they also have a fish diet as well. So fish and squid and flying fish, some flying fish. Yeah. Do you want us to say more?
And mostly a lot of squid, flying squid, yeah, and little flying fish.
But what we need to do more work on that.
Yeah.
I think, yeah.
The food's very digestive. Very.
Chicks are left alone for quite a period of time because to migrate. So how do you know if the parents are going to come back? What is the time frame for them to move on?
Well, we have done some GPS tracking during the time when the chicks are being fed, and it can be 2 days, but it can also be up to 14 days. So there can be, that's our maximum trip length was 14 days away from the chick, but there's 2 parents, right? So you're hoping to get another feeding.
And they rotate. So if they're gone more than 14 days, is that a concern for the chick?
Yeah, that starts to be hard. I think that, well, what we assume is that dehydration starts to get them, if not starvation. But dehydration is probably first because that's where they're getting their water from.
So what do we do if we have a chick and it's, because I have a lot of them, you know, and it's been past 14 days. Is that something that I should be concerned about? Or is it?
Yeah, I think it's best that you really have to let the parents take care of it because it could be day 15 that it comes back, you know. And you could, and Colleen's had to deal with this a little bit too in her house. So, yeah, I think the best course is to let nature take its course, and the parents could come back, and it could be okay because we don't know really the extremes of what a chick can handle. It depends also how fat was it when it started to be left, you know, yeah, or how young, or yeah. Yeah, but it's hard. You can't really give them a bowl of water. You can't. It's hard to help them.
Yeah.
Until they get older.
This time,
Yeah, we want to do that because we're investing a lot of time in spreading the message and hoping other people will use this. So we're hoping that we can get them down to a couple $100 a module. Right now, we've been in such research and development phase for everything, but right now it's really just like our time doing the ideas and the prototyping. But one thing about clay is it's super cheap. So, and I didn't realize this before, but you know, the clay was the smallest cost of this whole project. So if we can get it to be reproducible without extreme experts needing to have their hands on it, we can get it down to, you know, $200 or $300 a module. And then we have to sell the conservation community on the fact that if they just use a wooden box, it's cheaper. But these are going to last their lifetime. And they won't have to maintain them and repair them. And so that's going to hopefully be the advantage. But we have some students that are focusing, helping us on the kind of, I want to say business side, but the economics to make sure it's feasible.